Hello. Now we're going to have a look at some problem solving. So the steps we can take to make a complicated problem simpler, or how it is that we could approach problems, because maths is going to be all about big problems that we have to make into smaller, more manageable problems. And we're going to start looking at the process of doing that now. Two friends have different spending habits. On day one, Jack has €10 and spends €2 a day after that. Ava has €4 on day one and saves €1 a day. When do they have the same amount? So when do they have the same amount of money? Well, the first thing we need to do is be very clear for ourselves. What are we being asked? What is the thing we're actually looking for? And we're asked, when do they have the same amount of money? So when is Jack's money? So Jack's money, I'm going to call J. So Jack's money I'm going to call J so that I can keep track of it more easily. And Ava's money I'm going to call A, so that I don't have to keep writing Jack's money and Ava's money. I can write just down J and capital A, and they're going to mean Jack's money and Ava's money. So I can more easily keep track of things that way. So I want to know the day when Jack's money is equal to Ava's money. When they have the same amount of money, they would have an equal amount of money. Say, if each, this isn't going to be the answer here, but if they both had €10 on a particular day, then they would have an equal amount of money, or the same amount of money. So I'm interested in what day does Jack have the same amount of money as Ava? Or does Ava have the same amount of money as Jack? And equals means the same as in maths. So that's my problem defined. I know I'm looking for a day when the money that both of them have is equal. So how can I translate this? Well, that means take the English that I've got here and can I turn it into more concrete mathematical things that I know about? Well, I know the money that Jack has, I've called J, and the money that Ava has, I've called A. So what way does that work? How does Jack's money work? If we take Jack's money first, he starts with €10, and then each day we take away €2. So minus €2 each day, because he spends €2. Starts out with €10, spends €2 each day. What does A do? What does Ava's money do? Well, she starts out with €4 and she saves €1 each day. So what's going to happen with her money? Well, it's going to go up by €1 each day. So that's how those are going to change as we go on. Now, how could we use that? How could we solve our problem? Well, if we wrote down how much money each person had each day and saw if there was a day that they had equal money, that they had the same amount of money, that would be a way of solving our problem. Or if we drew a picture of it, and drawing a picture or a diagram is often a key skill. So drawing out lists or tables of things can help us to solve problems, and connected to that, drawing graphs, plotting graphs of things can help us hugely with seeing and understanding the problem that we've got. So how are we going to engage with our problem? What we're going to do is draw out a table. Or a grid effectively of the money they have each day. And we are then going to draw a graph. And by the time we've drawn our table and our graph, we'll have a pretty good idea of what's going on in this question. And finally, we have to do this one at the end. We're going to see if interpreting our work does what we've said make sense. So let's start off, and we're going to draw our table of Jack's money. So we start off with Jack. Let's make our table, and we're going to have days. And what we want to do when we are making our tables, actually, I will use a ruler here to give you straight lines, because when you want to make tables out, you'll often want to keep them quite neat. It'll be important for us to keep everything neat and tidy as we're working, or we will tend to make a lot of mistakes. As the problems get bigger and more complicated, the neater and neater we need to be. If our work is all over the place right now, we might get away with it, but very quickly maths is going to get much more complicated. So we want to try and keep everything as neat and tidy as we can. So I've made a table, and I've gone for a particular number of days. I've made a bit of an error here in that I'd like to have more space to keep going, but we'll see how we get on here. So on day 1, we know that we have €10, and we know that each day Jack is going to spend €2. So the next day we're going to have €10 minus €2 is going to be €8, and then €6, and then €4, and then €2. And then Jack has a problem because he doesn't have any money anymore. So we have to stop at that point. We're not going to say that Jack goes into debt. He just stops at that point. Now we need to do the same thing for Ava. Now I've drawn out my neat table for Ava, and ideally I would have left myself more space, but I'm a little bit cramped on my screen here. So on day 1, we know that Ava has €4. And on the next day, she will have saved €1. So we know that our money goes up by €1 each day. So €5, then €6, then €7, then €8, then €9. Well, what I can now see is something that's common in both. On the third day, I can see that both people have €6. So this is my day that I was looking for. What was I looking for? I was looking for, when I defined my problem, the day when Jack's money equaled Ava's money. Well, on the third day, Jack has €6 and Ava has €6. So on the same day, they have the same amount of money. So the table has solved this for me. But to me, it's actually a little bit difficult to see when they are that we have the same amount of money. I can pick it out, but a graph, particularly for a more complicated problem, would help me a lot. So what we're going to do is draw a graph. So what I did was I looked at the number of days I needed to take into account, and I made my x-axis that many days long. I had to go from 1 to 6. And for my money axis, I could see my biggest amount of money that I am covering in the table that I've got is up to 10. So I'm going all the way up to 10 on my money axis. So on the y-axis, I have my money, and on the x-axis, I have my days. And the more fundamental thing, days will keep going by no matter what our friends do with their money. So the days are the more fundamental thing, so they're going to stay here. They're the independent variable, and the money is going to go on the y-axis because it's the dependent variable. Now, let's draw in our two relationships, our two patterns that we've effectively got going on here. So here I have day 1 and €10 for Jack. So the coordinates of that would be 1 and 10. For the second day, it would be 2 and 8 and 3 and 6 and 4 and 4 and 5 and 2 and 6 and 0. Those are the coordinates for Jack. I'm going to write them in for Ava. So I have my x and y coordinates, my days and money coordinates for Ava. So Jack's I'm going to do in this orange-red color, and the turquoise I'm going to do for Ava. So let's start with Jack. On day 1, he has €10. Always start at the origin at 0, 0. Day 1, €10. That's the first point for Jack. Day 2, €8. In the door 2, up the stairs 8. In the door 3, up the stairs 6. In the door 3, up the stairs 6. In the door 4, up the stairs 4. In the door 5, up the stairs 2. He only has €2 left, and then on day 6, he's in trouble. He's got no money left. Then for Ava, let's change color. Ava on day 1 has only €4. But Ava is very sensible and she's saving money, and each day she goes up by €1. So we can actually figure it out from the graph. If we go up, if we increase the day by 1, she's saved an extra euro, and that works out. That's our point. So we have day 2, €5. In the door 2, up the stairs 5. And then we have our thing we were looking for. We have in the door 3, up the stairs 6. And in the door 4, up the stairs 7. In the door 5, up the stairs 8. And in the door 6, up the stairs 9. And now with this picture, it's extremely easy to see. When do they have the same amount of money? Well, I can see here at €6, I go to this point here, in the door 3, and I go up and across, and I'm at €6. So after 3 days, they both have €6. Now I can see from my graph, and from my table that this makes physical sense. This person, Jack, starts off with a bunch of money and is spending a bit each day, and Ava starts with less money and she saves a bit each day, so her money goes up each day. It makes physical sense that they are able to have the same amount of money on a particular day. So there's nothing logically wrong with my answer. I can see that it makes visual sense. I have my linear patterns that make visual sense. I can see that it makes sense in my tables. I can see the story that got me to this point. So it makes sense that as Jack's money is going down and Ava's is going up, that they can have the same amount of money on the same day. I'm going to write that in now. So for our final bit, as Jack starts at €10 and goes down €2 a day, and Ava starts at €4 and goes up €1 a day, both having €6 after 3 days is okay. It makes sense. And we won't always have to write that, but it's important that we're training ourselves to say at the end of a question, does that make sense? Did I end up with some funny number that doesn't make any sense at all? And if we train ourselves in that, it can help us to be better at problem solving, which is what maths is all about. And that's what we need for now.